Hello everyone. This is the last video for the week. So today we're going to work on adding and subtracting rational expressions. We started with multiplying and dividing, which I know is a little backwards, mainly because it's a lot easier, personally I think, to multiply and divide, because it doesn't matter what your denominator is. When you're adding or subtracting, you have to have a least common denominator. So that's where it's going to get a little bit tricky from what we're used to. Okay. So looking at this right now, in order to add or subtract fractions, we must find the least common denominator. So let's look at some fractions that we've probably done before. A least common denominator here, we could get 12, because 12 is a least common denominator of both 3 and 4. So we're going to multiply the left one by 4 in the numerator and denominator to get it equal to 12, and the right one by 3 in the numerator and denominator. 4 times 1 is 4. 4 times 3 is 12. 3 times 3 is 9. 4 times 3 is 12. We add these and get 13 over 12. So it's all about least common denominators. Now, you can choose a higher one. It just means you're going to have to reduce. So instead, 24 is also 1 here. I will multiply the left one by 8 to get 24 in the bottom, and the right one by 6 to get 24 in the bottom. But then I would get 8 over 24 plus 18 over 24, which gives me 26 over 24, and then you have to reduce. It's still going to give you 13 over 12. All right, and for the last one, a common denominator there could be 48, but 24 is the least common denominator. So we're going to multiply the left one by 3, the right one by 4, and we get 21 over 24 is equal to, minus 4 over 24. 21 minus 4 is 17. 20 over 24. The denominator stays the same. Sorry, I forgot that it was subtracting this time. So likewise, we have to do the same thing with adding and subtracting arithmetic of rational expressions. So I've been using, in my other class, we've been doing arithmetic sequences. It's pronounced differently when you talk about sequences. So here, the big thing is determine what the other one is missing. So this has an x plus 1, this has an x minus 1. They're different. So what I can do is I can multiply this one by x minus 1 and this one by x plus 1. If you're ever finding a common denominator, remember you can multiply the denominators to figure it out. And here I would get 3x minus 3 plus 4x plus 4 all over x minus 1 times x plus 1, because the denominator is the same. We combine like terms, and we get 7x plus 1 over x minus 1, x plus 1. Sorry, I'm going off the page there a little bit. All I did was combine like terms. 3x plus 4x is 7x. Negative 3 plus 4 is 1. Denominator stays the same. Here, this one has an x plus 3, so does this one, but this one also has an x minus 1. So I need to multiply the left one by x minus 1 to make sure we have common denominators. So we're going to have 2x times x gives me 2x squared. 2x times negative 1 is minus 2x. And then we're adding 4x all over x minus 1 times x plus 3. Combine like terms. Negative 2x plus 4x is 2x. I'm going to take out the GCF of 2x and get 2x times x plus 1, because this gave me 2x, so it's 2x squared plus 2x, and then I get x minus 1, x plus 3. We still have to make sure to factor because we might be able to simplify. And then for C, I have to multiply the left side by x minus 1 because that's the denominator of the other side, and multiply the right side by x plus 3 because that's the denominator of that side. So I get 2x. Sometimes it's easier to just leave it out, so we're going to do that for this time. So I get 2x times x minus 1 minus 4x minus 12 over x plus 3 times x minus 1. Now, as it is right now, I'm not going to be able to, so I do need to distribute this 2x. So I get 2x squared minus 2x minus 4x minus 12 over x plus 3, x minus 1. Combine like terms and take out GCF at the same time, trying to reduce this. I'm sorry, I'm going kind of over here. I would get 2 parentheses x squared. This becomes negative 6x. Take out the 2, it's negative 3x. Negative 12, take out the 2, it's minus 6. All over x plus 3, x minus 1. I'm trying to see if this is not factorable, so we should be okay. We are all good. Now, I did tell you that in a later video we were going to talk about what do restrictions mean. And restrictions mean before you simplify, what can x not be, because it's going to give you a denominator of 0. So this can't be simplified anyway, but x here cannot be negative 3, because if x is negative 3, negative 3 plus 3 is 0. 0 times whatever this is going to be 0. We're not allowed to divide by 0, and it can't be 1. So it's pretty much take these factors in the denominator, find the roots or the zeros, and that's what x cannot be. And that is how you do your restrictions. So we're going to add those in as we do this today. Determine what each denominator has that the other denominator is missing. Then multiply the top and bottom by whatever is missing to give you the common denominator. So here, a common denominator between 6, 3, and 4 can be 12. So to get this to be 12, I got to multiply by 2. To get this to be 12, I got to multiply by 4. To get this to be 12, I got to multiply by 3. So I have 2 over 12x plus 8 over 12x minus 3 over 12x. 2 plus 8 is 10, minus 3 is 7 over 12x. Now, x cannot equal, if I set this equal to 0, it can't equal 0. Because 0 times 12 is 0, you're not allowed to divide by 0. Example 2. We're going to keep going with these. So this has an x, a y squared. This has a 4x and y. To make these look equal, I need a 4 over here. So we're going to multiply by 4 over here. I need another y over here. So we're going to multiply by y over here. Okay? So now that I have that, 4 times this is 20y plus 2 over 4xy squared plus y times this is 2xy minus 4y over 4xy squared. The only like terms are 20y and negative 4y. So when we add those, first we're going to get 2xy. 20y minus 4y is 16y. It's a positive 16, so we're adding. And then plus 2. And then this is all going to go over 4xy squared. Now here, the x can't equal 0. And what I'm doing is an equal sign with a line through it. And y can't equal 0. Neither the x nor the y can equal 0. Okay. For the next one, I have a 7 here, a 21 here. So to get this, I have to multiply by 3. I'm leaving it open because I might have to multiply by something else. I have x squared here. I only have an x here. So I got to multiply by x here. I have a y here, y squared here. So I need another y over here. And that finishes it off. 3y times 3 is 9y. X times 4 is 4x. And the bottom is 21 x squared y squared. And here again, x, these can't combine, but x cannot equal 0, y cannot equal 0. Those are your restrictions. Because if x is 0, 0 times this is going to be 0. If y is 0, 0 times all this is 0. Okay, for the next one. We have a 8 here, but a 4 here, so we need to multiply by 2 over here. X cubed here, only x here, so we need to multiply by x squared. Y cubed here, only a y here, so we need to multiply by y squared. The left side does not need to be multiplied by anything. So we have 3 minus 1 times all this is 2x squared y squared all over 8x cubed y cubed. There's no way to factor that or do anything else. Again, here, x cannot equal 0, y cannot equal 0. Okay. Continuing on. Now, when you have a binomial or a trinomial denominator, you factor and find a common denominator. So we're always going to start by factoring everything, and then we'll multiply the top and bottom by whatever is missing and combine the numerators. So first of all, we're going to factor. I get w plus 12 over 4 times w minus 4. So I took out the GCF of 4. And here minus w plus 4 over, take out the GCF of 2, w minus 4. So both the denominators have a w minus 4. This has a 2 and this has a 4. So I need to multiply the numerator and denominator of the right one by 2 to get this to be 4. So what I get is w plus 12, and 2 times w is 2w, and it's a minus, so minus 2w. 2 times 4 is 8, and it's a minus. This whole thing is going to be minus, so we have to remember that minus. So minus 8 over 4w minus 4. So now we combine like terms. W minus 2w is negative w. 12 minus 8 is a positive 4 over negative 4, w minus 4. Now I can factor out a negative 1 in the numerator, and I get w minus 4. And, sorry, this is nothing over here. 4, w minus 4. Now these are going to cancel out, and I'm going to get negative 1/4. But we do have a restriction, because before they canceled out, w minus 4, we have to set that equal to 0, and we get that w cannot equal 4 here, because 4 minus 4 is 0. So it's before you do that. Number 6. So looking at number 6, let's take out our GCF. So we have y over 2, y plus 2, minus 3 over y plus 2. This is just missing the 2, so we're going to multiply it by 2, both the numerator and denominator, and I get y minus 6 over 2y plus 2. And that's the answer. You cannot reduce this anymore. And after I do that, I am going to make sure that I write the restriction. Y cannot equal negative 2. Okay, next up. My dog's asking me to go to the bathroom. So next up, we have negative 3x over x squared minus 9 plus 4 over 2x minus 6. So first I'm going to factor. I'll get negative 3x over x plus 3, x minus 3, plus 4 over 2, x minus 3. So on the left side, we have an x plus 3 we need to multiply by. And on the right side, I have a 2 I still need to get. So I'm going to multiply this side by 2. So I'll get negative 6x. Negative 3x times 2 is negative 6x. 4 times this gives me plus 4x plus 12 over 2x plus 3, x minus 3. Combine like terms, and I get negative 2x plus 12 over 2x plus 3, x minus 3. I'm going to take out my GCF, which is a negative 2 on the top, just to double check. And I get negative 2x minus 6 over 2, x plus 3, x minus 3. The negative 2 and the 2 are going to cancel out, so it's just going to be negative x minus 6 over x plus 3, x minus 3, where x cannot equal negative 3 or 3. Sorry, and we're slightly running out of room there. Okay, for the next one, let's first factor. We get 2x over x minus 2, x plus 1. I'll let you guys out in just a second. Minus 4x over x minus 2, x minus 1. So we need to multiply the left by x minus 1 and the right by x plus 1, because that's what's missing. Okay, now when we do this, we have 2x squared, 2x times x, 2x times negative 1 is minus 2x, minus 4x times x is 4x squared, negative 4x times 1 is minus 4x, over x minus 1, x minus 2, x plus 1. Combine like terms, and I'm going to get negative 2x squared minus 6x all over this. Take out GCF, and I get negative 2x times x minus 3 all over x minus 1 times x minus 2. This should be x plus 1 times x plus 1. That is fully simplified. Sorry, this should be x plus 3. That is fully simplified. X cannot equal 1, 2, or negative 1. I'm going to double check because I have my answers on another sheet of paper that I worked out. So I'm double checking real quick that is it. Kind of a long thing, but yep, that is it. All right. We are only going to do one more example. So we're going to do example 9, and then there is a quizzes for you to do. So let's do example 9. So let's first factor out 5x over x minus 3x plus 2 minus 4 over x plus 2, x plus 2. Now, this has 2x plus 2, so we have to multiply this by another x plus 2. This has an x minus 3. We got to multiply this side. So x minus 3, x minus 3, x plus 2, x plus 2. We get 5x squared. 5x times 2 is 10x. This is negative 4 times x is minus 4x. Negative 4 times negative 3 is plus 12. All over x minus 3, x plus 2, x plus 2. So now we're going to combine like terms, and we get a 6x here. So we get 5x squared plus 6x plus 12 all over x minus 3, x plus 2, x plus 2. And I'm really quickly thinking in my head if that is factorable. In fact, let's check Desmos to see if that's factorable, the numerator. So we're going to get 5x squared plus 6x plus 12. And as you can see from Desmos, it is not factorable. So that is going to be our final answer, where x cannot equal 3 or negative 2. Remember, you can always check Desmos to see if it is factorable, and it'll be factorable if it has a root that is real. All right. So now you guys are going to do your own with quizzes. You are more than capable. I believe in you. You guys got this. Have a wonderful day. If you need any help, know that I am just a phone call away.